download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about polymers. Now polymers are very long molecules with atoms held together by covalent bonds. So if we look on this diagram here, which is an example of a polymer, it's polymethane. There's a strong covalent bonds here between each of the short repeating chains of the polymer. Okay, so these here are connected by strong covalent bonds. However, okay, the molecules, so this molecule here and this molecule here, are held together by intermolecular forces, which are these dashes here. Now, just like with when we looked at our simple molecular substances, these are weak intermolecular forces. Okay, so these are weak intermolecular forces. So we have here a polymer, which is a long molecule with atoms held together by their covalent bonds, and then the polymers, the molecules of polymer, are then held together to another polymer, molecule of polymer, by a weak intermolecular force. Okay, now it's important to note, okay, that as a molecule increases in size, as a molecule gets bigger, so as a molecule gets bigger, the intermolecular forces, which remember is the forces that hold the molecules together, so these here, get stronger. Okay, so if we compare methane, which is what we looked at last video, okay, now if we compare two methanes being connected by a weak intermolecular force, because these molecules here are larger in size, they are bigger than our methane, which is our simple molecular structure, these bonds here, these intermolecular bonds, will be stronger. Okay, they'll have stronger intermolecular bonds, intermolecular forces than these, which means that polymers have a higher melting and boiling point than simple molecular structures. So polymers have a higher melting and boiling point than simple molecular structures, which have a lower melting and boiling point. Okay, so this is why they are normally solid at room temperature, whereas when we looked at our simple molecular structures, most of them were gases at room temperature, some of them were liquids, but this is why most polymers are solid at room temperature, because they're larger molecules, they're bigger molecules, therefore the intermolecular forces are stronger between them, therefore they are harder to break, and therefore they have a higher melting and boiling point. So the things to really note from this video, the really important things to remember, is that polymers are very long molecules with atoms held together by covalent bonds, and that they have higher melting and boiling points than simple molecular structures. And that is because they are much bigger molecules. As a molecule increases in size, the intermolecular bonds get stronger, and therefore it requires more energy to break, and therefore they have higher melting and boiling points. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. So now I'd like you to do quite a short video, that one, but have a go at answering these questions. Now polyethylene, just to give you a clue for this one, I mean the clue is kind of in the name, but it is a polymer. Okay, so polyethylene is a polymer. So now have a go at answering these questions. Pause the video now. Okay, so let's run through the answers quickly. So number one, polyethylene is made of carbon and hydrogen only. Methane is also made of carbon and hydrogen only. Why does polyethylene have a much higher melting point than methane? Okay, now that is because polyethylene is a polymer. And a polymer is a long molecule, a long chain, okay, a large molecule. Larger molecules are attracted to each other by a stronger intermolecular force than simple molecular substances. So that means that the intermolecular forces between polyethylene are stronger than the intermolecular forces between the methane molecules, and therefore they have a much higher melting and boiling point because those intermolecular forces require more energy to break. Question 2. Ammonia is a simple molecular substance. Explain why it has a low melting and boiling point. Well, that's because it has weak intermolecular forces which require less energy to break, and therefore they have a low melting and boiling point. I'm really hoping what you're starting to realise here is that melting and boiling points are very easy to answer. If they have a high melting and boiling point, that's because they have strong bonds that are hard to break and require lots of energy to break. If they have low melting and boiling points, that's because they have weak bonds or weak forces which don't require much energy to break and therefore have low melting and boiling points. And we can pretty much apply that answer to all of these different molecules. It's the same answer really. Number 3, explain why ammonia cannot conduct electricity. Okay, ammonia is a simple molecular substance. Okay, and we said that simple molecular substances have no charge. Okay, because they are not ions, they have not lost or gained any electrons, they have no charge, therefore, and you need a charge to carry electricity. Therefore, it cannot conduct electricity because they contain no charge. Question 4. This is a bit of a throwback to the giant covalent structure video, so if you've not watched that, then please go back and watch this. But the answer is that giant covalent structures have billions of atoms chemically bonded and not just a few intermolecules. Okay, so that's the answer for that one. And finally, question 5. Polymers do not conduct electricity. Explain why not. Well, that's because they have no charge. They have no ions or no delocalized electrons, therefore no charge. And if something has no charge, they cannot conduct electricity. Okay, so the important thing there is no charge. So you have now learned about polymers and what polymers are and how they have a slightly higher melting and boiling point than simple molecular structures and why that is. If you understand this, then please go on to the quiz and answer the exam questions. If you need a little bit more help, then please do get into contact with one of our tutors who will be happy to help.